And now we move on to our next presentation. José Ramon Padilla Lopez, again the same research team. He's going to talk about the automatic generation of user interfaces for digital home, case accessibility for for blind people. That's another very interesting presentation, because again we're addressing interfaces. All right.
I'm trying to investigate. Doesn't even detect.
Vale. Hola a todos.
Hello, my name is José Padilla, and I want to talk about is language development for user interface for digital home services. I'll give you this slide. I'll just skip this slide here to get more time. And this is the introduction. The development is to make independent the user interface from the application. The user interface is a very important component because in it includes the interaction between the user and the application. And so things such as usability of the application are also very important. And these concepts also give a better form the life assisted by the environment, and this has to be accessible and usable by all people, in fact. This also aligns with, this is also appropriate for design for all, use for all, but in principle, these elements are not used in general, and the most common user interface, as an example, is a graphic user interface. Obviously, anyone that's blind, the graphic user interface could not be used correctly if you're blind. And so in order to make a graphic user interface, to make it accessible to all, there are different approaches, different methods. For example, screen readers that read out the different elements that you have in the interface, or be using improving the user interface with information or tactile. So the information through this interface is then represented in non-graphic interfaces, or devices rather. And a third is the use of the dual interface, user interface, which is two interfaces, visual and non-visual, that adapt to the user's needs. In addition to accessibility, another problem that we need here is portability of the interface, of the applications. There are many platforms that you can develop, that you can use to develop applications, and if you want to support them, you have to develop an interface for each one. So the solution here would be to have a user interface language which will enable us to go user to user, and develops in a descriptive way the interface in such a way that in the design and execution phase, the description is processed to then generate the final interface, and that's the one that the user will actually see. Let me define a user interface through. They did do this, in fact. That goes back to the 80s, mid-80s. These systems wanted to split the logics of the interface from the application using different models. However, this wasn't enough. And to make it fully independent, the user interface, make it fully independent from the platform, that's when we get the description language, the UDLs. The languages are all based on XML, owing to the advantages that this language has. And what we've seen while reviewing these is the interfaces that it describes through this work are it's done using these languages. But these are languages used to write more generic interfaces, so we need to cover a greater scope, a greater range of interfaces, so we add a different complexity. And also in these commercial languages, we find that this is very much tied, linked up to the appropriate platforms, and then normally used to write graphic interfaces. So other works that are more aligned with our current needs is the RUC Cook, where we've developed a language for the interface for remote control, which is really what we're after in this work. Language specifications, we followed the following design. First of all, it has to be an easy syntaxis, easy to analyze, to interpret, and to manipulate. The description has to be able to be processed and then develop the final interface. So we think that the grammar, so to speak, has to be in XML, and as well as, and we've reviewed the. We also think it has to have a high level of abstraction. In other words, very independent from the final presentation, the mode, and the platform. We also think that part of the complexity must be done by the component that manages by the component that interprets, the compiler, basically, and choose the mode of interface, either visual, voice, touch, or what have you. And the language it cannot use any interface except for it will be focused strictly in these terms. And for a digital home, we find that the functions can be modulated with inputs and outputs, or the user actions that lead to a response in the services provided by the home. So this is a design that can be used to modulate, and where we have an action, a query and a response.
So here we've got two sections. First of all, the description of home services. And here we've got actions and responses, as I already said. And this is all about static elements and dynamic elements, which is the form part of the description of the interface, the user interface. And so we have launchers, which is the linking point between the two descriptions that we see here. And further on, we'll see what this is all about. If we talk about the description of the services in the home, we have actions, which are those which modify the current state of a device in the digital home, and the responses, which, rather than change them, they modify them and they check the status. The actions, we have four. The first one, the simplest action, which allows us to use a device, basically, for example, to switch on a light. The second option, what we would have would be, well, it would depend on the device in question in the home. And according to its status, you'd be able to activate one option or another. For example, in the case of a light, you could offer the user the choice of switching it on if it's off, and vice versa. If we have option action, what we're doing is presenting the user with another functionality for the device, which with useful options. For example, if you've got a blind, we can have a blind with 0 to 256 as the values. 0 would be the blind completely down, and 256 could be completely up. But you're not going to give the user 256 options, but rather we'd give them the choice of have it down, halfway down, or completely up. If we talk about numeric input action, this is for actions. Well, in these cases, we have a range of values, and we want to make them available to the user. If we think of a thermostat, the function may be altered, for example, between 18 degrees and 30 degrees. Using this device, the user can select a different temperature. With regards to answers or responses, with query, we can find out the status of a device, but this is done in a numeric way.